Well, hello, or should I say, welcome to the future of software management with Docker and container tooling. This video is specifically about Docker. It had lots of tools over the years, but this video is about the three major innovations that started the Docker whole evolution of software in 2013. That is mainly three things: the Docker image, the Docker registry, and then the Docker container. Most of us, when we think of Docker, we think of the container, but these three innovations go together like bread and butter. And they call it at Docker, build, ship, run. Those are the three steps to take previously non-containered software, turn it into a Docker image, put it on a registry, get it to wherever you need to run it, and then finally create a container from it. In fact, the CNCF, or the Cloud Native Computing Foundation, which a lot of the tools we'll talk about throughout all my videos, those products and tools and workflows make the assumption in most cases that you are using a container workflow of build, ship, run. So let's break these down and exactly what the three are. First up, the container image. And I like to think of it as a universal app packager. And we've had lots of package managers over the years. In fact, I've lost count, and I've been around a while, of all the package managers. But there's never been anything that I can recall that's been cross-OS, cross-platform, and application language agnostic, meaning it will run everywhere and it runs on anything, as long as it's running Linux or Windows. Now let's take a real quick look at a Docker file, which is the recipe or set of instructions to make a container image. Docker image and container image are the same term for the same thing. In fact, the Docker image specification was so popular, it's now a standard known as the OCI image standard. So you see a set of instructions, and every Docker file needs a from to start with. We can start from someone else's image. We can have many images from many froms. So we'll get into all that complexity later, but we're starting with a Python here, and we work our way down. In fact, we start with these as layers. Each one of these commands in the Docker file, sometimes called a stanza with capital letters, including the from and then the run, and working their way down because it processes them from the top down, will create layers which get moved around servers as tarballs, and inside those layers are files, directories, and file permissions, and sometimes metadata that we'll get into later. When I start building this image, it will start that first line and go find the Python image from Docker Hub or wherever I told it to get the image from. And that includes just Python, its binaries, and its libraries. It doesn't contain host drivers or the Linux kernel or anything outside of what Python needs to run. If Python needs OpenSSL, then that's included in that layer of the image. Then we can move on to the next line in the Docker file. That's a pip command for a Python dependency installer, and it's installing Flask. So that will start a new layer that adds Flask, just like you would with a normal pip install command. In fact, what's happening in the background is we're executing quick little containers for each of these layers, running the commands or doing whatever you need to do inside those layers, and then storing them as their own distinct location on the Linux host that's building this. So we're stacking up layers here. And then we go to the next line, the copy command. The work there is just a metadata change. It just changes locations in the file system. No big deal. The copy command copies our source code from the host we're building on into its own layer stacked on top of the others. These together form an image using the command docker build. This is one of those things about Docker that became so easy to use because we only needed this simple docker build command to take a bunch of complex things going on in the Docker file and turn it into a single image that is just our application and only the dependencies that it needs and nothing else. That's the first part of the build, ship, run, being Docker build. Next up, let's talk about the registry. The Docker registry is for application distribution. Every application packaging system has a way to get those packages around. And the Docker registry is no different. Now it's just known as the OCI distribution spec or OCI registry specification. So it's a standard, again, in the whole industry for how to move container images around. And it is everywhere. Every cloud has one. Docker Hub is the default and probably the most popular. GitHub has one, Bitbucket, GitLab. They all have their own image registries, and you can run your own. There's probably at least a dozen projects of free open source and paid software that allow you to store your Docker images in them. So let's break down how that works. First, we have our image that we just built, and that image has a unique SHA hash that identifies all those layers together in a way that we can guarantee that if we look at the hash on two different systems, we can be certain that it's the exact same files, the exact same metadata that we just built. Those image layers go together and distribute themselves. We can use something like Docker push to take those image layers and push them up to a registry. You can use one of many registries, like I mentioned, but once it's there, you can then go to another machine and do a Docker pull, which will pull an identical copy of that image down on that machine, just like we had built it on the first machine. And this is one of the core principles of Docker, is that we're able to take the software that we made on one machine with all of its dependencies and run it exactly that same way on another system that might be completely different distributions of Linux or Windows. If you're on Linux and you build a Linux image, which has to run on Linux since it's running Linux binaries, if you built it on CentOS and you ran it on Ubuntu, it would be the exact same application and dependencies regardless of that distribution. Finally, we get to the Docker container itself. Once we've done all those steps of building the image, putting it in a location we can access it from our servers, and then downloading it into our servers, we can run it. Let's imagine we have a server running Linux. It might be running Windows, but in this case, we'll just focus on Linux. It's going to have Docker running in the background. That's known as the Docker engine. And the engine on this single machine will orchestrate or manage all the different things that need to happen in order to download images, verify that they're the exact thing that was meant to be downloaded, and then finally run them. Then we got the image we just downloaded with a Docker pull, and then we're going to run a command. It's not really important that you learn the commands yet, but it's a Docker run command. This is the run part of build ship run. And in this case, we're running that Python app in its own container. That container is known as a namespace. That's the Linux feature that prevents the application running in this container from seeing the rest of the operating system. It gets its own blank file system, and it will only include the files that were in that image we just built. It'll get its own IP address and its own virtual NIC and its own process list, and basically looks like its own system inside there. Then if we run that Docker run command again with our image name or image hash, then we get an identical container running side by side. Now these two processes are isolated from each other. So the Python app in container 1 can't see the Python app in container 2. And if you change a file in container 2, container 1 won't see that file by default. If we added a second server with a second instance of the Docker engine running and did the same thing, we could have a highly available setup with our application running many times for redundancy or better performance or whatever our reason might be for running more than one of them. They will be identical from the point of view of the file system, the permissions, and the metadata. Now, there's a ton more that we can learn about this stuff, which is why the course that I have is so long now. But these are still the three things that haven't changed after Docker first conceptualized them. The build, ship, run idea is one of the core principles of containers and Kubernetes, Helm, you name the project in the cloud native ecosystem, and it probably assumes you have this typical kind of workflow for getting your apps out of your developer hands into the testing systems, and then finally into production servers. It's these same three steps. So hopefully it's starting to sink in just a little bit that you get why these are the three key components, even today, many, many years after all this was invented. Let's find out what's next.